All right, we're going to do the last two problems using the quadratic formula. Okay, so that's the last two examples on guided notes D. All right, so let's see. We're getting used to the quadratic formula. It's the same every time. You don't have to remember how to factor. It looks like a complicated formula, but it's really just the order of operations. All right, so these are the two that we're going to do. Let's do 4x squared minus 1 equals 2x. Now, right away, you'll notice that this needs to be 0. So we're going to move this over like here. That's going to be 4x squared. That needs to go in the middle. It does. Neither one of these are like terms. This needs to be the middle term. That's going to be minus 2x minus 1 equals 0. Okay. Identify what A, B, and C are. A is 4. B is negative 2. C is negative 1. All right, now let's write down the formula. You write it down every time you get used to it. This is our formula, and the parentheses are where we insert the numbers. Now, what goes here? That's B. Now, remember, this negative is from the formula. This negative is on the 2. That's it. That's also B. This is A. This is C. And there it is again, minus a negative. That's going to turn into a plus. And 2A, that's 2 times 4. All right, order of operations. That's a positive 2, plus or minus. That's going to be negative 2 squared is 4. And this is going to be plus because it's a minus times a negative again. 4 times 4 times 1 is 16. And this is all over 8. Now, 4 plus 6. Now, you're going to say, whoa, wait a minute. 20 is not a perfect square. What do? This is called this is called an irrational answer. I mean, it doesn't come out to a nice number. Your answer is going to have a square root in it. That's okay. Now, do you remember how to break up the square root of 20? I hope so. That's 4 times 5, remember? And then 4 is 2 times 2. All right, if you have a pair of 2s, you can put 1 2 on the outside and leave that 5 on the inside. Another way to do it, the way most of you learned, maybe, you break that up into the square root of 4 times the square root of 5. You know that the square root of 4 is 2, so it's 2 square roots of 5. So break up 20 like we did back in Unit 8. This breaks up into plus or minus 2 square roots of 5 all over 8. Now, this can be reduced again. I'm going to put dots here, here, and here, not the 5. If you can reduce 2, 2, and 8, all three, by the same number, you can reduce it. But if even one of them can't be reduced, you don't. All right, so let's see. We can reduce 2, 2, and 8. We can reduce them all by 2. So that's going to become a 1 and 1 all over 4. Now, just like if you have 1x, you don't need to write the 1. You don't need to write this 1 in front of the square root of 5. So you can just write it like this. And that is your final answer. Now, on the SOL, this might be written out as 2 separate answers. 1 plus the square root of 5 all over 4. And 1 minus the square root of 5 over 4. You can write it like this, or you can write them together like this. It doesn't matter. Either way is fine. Now, up here, this is actually correct. 2 plus or minus the square root of 20 over 8, but you should reduce it by breaking up the square root and reducing all three of these numbers at the same time. Now, let me give you another example. Suppose I had, just pretend, like I had 6 plus or minus 3 square roots of 5 all over 12. Could you reduce that? You would have to reduce the 6, the 3, and the 12 all by the same number. Can you do that? Yes, you can reduce them all by 3. That would be 2. That would be a 1. You don't have to write the 1. And that reduced by 3 is 4. So that's another example of how you would reduce something like that. All right. I just made that up. That has nothing to do with this problem. Now, also, when answers look like this, when answers look like this, it wouldn't have factored. Factoring would not have worked. If you tried to factor this, you would not have been able to find numbers that fit in the x. It doesn't factor. So when answers have square roots, factoring wouldn't have worked anyway. All right, you got one more example to do, and that is 5x squared plus 5x equals -5 minus x squared. All right, so immediately we see we've got to move the x squared over. When you move that over, it's going to join up with that 5x squared, and it's going to become plus x squared. When you move the -5 over, it's going to be behind the 5x because that is a constant term. It doesn't have a variable on it, so that's going to be plus 5. Now, what is 5x squared plus 1x squared? That's going to be 6x squared. The 5x is going to stay 5x, but that -5 is going to become plus 5 when you move it over. So this is what the equation looks like in standard form. We've got 0 on one side. All right, let's identify. A is 6, B is 5, and C is 5. So let's write down the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, so what are you going to put here? You're going to put b here, b. Here is a, here is c, and here is a. All right, let's use the order of operations. X equals -5 plus or minus the square root of 25. Now, this is going to stay minus because I don't have another negative down here. Let's see, 4 times 6 times 5, that's 120. So that's minus 120 all over 12. Now, I want you to look carefully what happens on this one. All right, 25 minus 120. That is -65. Now, this gets a big oops. You cannot have a negative number underneath the square root. So if this ends up being a negative number after you do all the operations underneath, if that ends up being a negative number, guess what? It's no solution. This problem has no solution. If you saw the graph, it looks like this. The solutions are where it crosses the x-axis. This doesn't even cross the x-axis, so there are no solutions. See, the solutions are where it crosses the x-axis, and it doesn't cross. No solution. It's because we got a negative under the square root sign. Okay, that is the end of Guided Notes D.